So going to be talking about GitOps, what it is, why it's important, and how you make use of it. So, standard agenda for that. The first question being, what is GitOps? To really talk about that, it's an idea, much more than a particular technology or even set of practices. Very similar to like DevOps. In fact, it's a natural progression from the normal DevOps approach of doing things. And as we all know, DevOps is no longer just about development and operations working together. There's a much larger cultural element to that. There's a lot of technologies associated with that. It's its own kind of thing that GitOps also, falls into. But that's what most of these are about as well. Is it's not necessarily specific technologies or practices, but it's a way of thinking, a way of approaching problems. As I kind of lay this out, it's definitely worthwhile to remember that it's not going to be a chronological timeline or anything like that, but it's things that build upon each other to give you a more robust way of approaching a lot of these problems. And a lot of this stuff, just even though it's been done for a very, very long time, even before they had names, like DevOps obviously was done before the term DevOps was coined. Because if dev and operations weren't working together, you were pretty well guaranteed not to have very good results. But the industry coalesced around the name so that they could be more efficient about gathering around a set of practices and build tools to support that. And while you can kind of do things that are higher on the list, you can't do it very well without the foundations. So, like DevSecOps obviously kind of requires DevOps. You can do it without. You can have development and operations and security talking to each other. That doesn't require DevOps per se. But it certainly works a lot better if you have those common artifacts that they can all work around. The next, of course, being infrastructure as code. Where you start, and this goes back to everything from, like Puppet and Ansible to, the shell scripts and the rest that sysadmins have always used for keeping their systems up to date. PowerShell for Windows things, though PowerShell is relatively recent. But, you get the idea. You want to script things. Infrastructure as code, as we'll talk about, it starts moving. The more modern idea for infrastructure as code is that it's taking a much more declarative approach to things as opposed to those scripts. But scripting definitely falls into that as well. And we'll talk about some of the differences and why that's been changing in a little while. And, of course, now is GitOps. But we're going to hold off on that to see how it fits into the larger picture. SRE, Site Reliability Engineering. This is the particular set of practices and technologies, but primarily practices that Google put forward on what works best for them, and they're encouraging everybody else to do the same thing. It's not just a Google thing anymore. And like DevOps, even though there were a handful of companies that kind of put that name and brand out there, it has grown into kind of a much larger movement within the industry. But so site reliability engineering really relies upon everything that comes before it. And the last on this list anyway, that's kind of the culmination of everything, is chaos engineering, verifying that things continue to work. People hacking your site, DDoSing your site, your servers crashing is not the same thing as chaos engineering. Chaos engineering is very much about doing things in a way where you're doing this stuff to yourself on purpose to verify that everything works. It's very similar to like all those automated tests that developers and QA and the rest do anyway, but in a production setting where you are intentionally stressing your environment to make sure that everything continues to work. The company that really put this on the map was Netflix, where they had Chaos Monkey originally, and then they developed a whole suite of tools around it that they called the Simian Army. That's been largely deprecated now. They've got other ways of doing that now with the more modern technologies. But this is what really put this idea on the map. And chaos engineering is certainly a very popular idea among the companies that cannot afford to go down. And again, it's just taking that whole idea of testing things and pushing it to their limits, but doing so in a way where, because you've been doing so, you know exactly how your system is going to react. And so you have your Saturdays and evenings back, because it's like, if in the case of like Chaos Gorilla, an entire availability zone goes down, you know, no services, no nothing from that zone is available. Everything still runs. Or, you know, in the case of like Chaos Kong, everything, you know, an entire region goes down. Everything still runs. It might be degraded, but everything still runs. You know, you're not dramatically affecting the business, as opposed to, for most companies, for most systems, like if a particular system or API call goes down, in many cases, it's, you know, kind of game over. Things just don't work properly. This is making sure that you know how things are going to react if you intentionally, in production, shut things down or do bad things to them. So this is very much an insurance policy on your systems. But that's, you know, kind of, you know, hey, the world is a cruel place. How do I deal with it? To get there, because you can't get there in a way that's going to save your sanity unless you have some of the things prior to it. And so let's start talking about that. Let's talk about GitOps. What GitOps is, and we'll flesh this out quite a bit more, is it's using proven development tools and techniques for information as code. So taking that forward, developers are very much used to the idea of thou shalt not deploy, but by continuous integration, continuous deployment. Back when I used to do a whole lot of consulting, it was not uncommon. It was distressingly not uncommon, to where I'd go into a place and they'd be like, oh, we'll just have Scott deploy that change. Scott would make a change on his machine, build it in his IDE, and FTP the code up to the server. No code check-in, everything based on his local configuration, what he happened to have installed on his machine, so no one else's build looked exactly the same, because it's all about, you know, that machine that happened to do that build. And that goes back to a lot of the stuff that where it used to be common for, you know, it works on my machine. Thankfully, with modern practices and technologies like ephemeral build machines, containers, that's the thing of the past, and we can move on to much bigger, nastier problems. But that has been, and sadly, a lot of places still do that kind of practice. But it's becoming recognized as being a very bad way to go. But that's a basis for moving forward. So let's move forward. Now it's going with basically not only developers thou shalt not deploy but by CI/CD, but operators you shall not deploy but by CI/CD. So no changes except by way of continuous integration, continuous deployment. So it's fully automated, the changes that are going to be made to the end system. So, you know, GitOps takes those DevOps practices that have been used for application development, such as version control, collaboration, test automation, compliance, and then says CI/CD is then going to be used for applying any changes that are made. And as purists of GitOps will note, I am referring to the push model, or usually referred to as the push model when people talk about CI/CD. That's not technically fully true for GitOps, but it's a well understood term. So we're going to go with it, and I'll clarify that a little bit more later on some of the technologies and techniques that are used, especially because of the particular demands of operations and infrastructure. So now that's what GitOps is. Now, why do we care? So we'll talk a little bit about our fun little Sam Straw Man. I'm sure nobody's ever heard these arguments be made before, but there's no way we can automate this. Our business is too special and unique. And the systems we put together are so complex that if Tony and Sally left, no one would have any idea what to do. You have no clue how irreplaceable we are for these big, complex systems. Right. Thankfully, I'm sure none of you have ever said anything that silly, but if you come across anybody trying to make an argument like that, there's a few counterexamples, like Google or Amazon, slightly complicated, complex companies that absolutely very publicly rely on GitOps. For example, Google's Borg, which is what Kubernetes came out of, manages thousands of deployments every single second, billions per week. And shockingly, they don't hire every single human on the planet to oversee and babysit things for when they do go wrong, because of course things go wrong when you're doing something that often. But they rely on GitOps for making sure that everything happens smoothly and can repair and heal correctly when they do. Amazon, very much in the same boat. Both companies have kind of grown a little as of late. Another big user of GitOps is the Department of Defense in the U.S. So the U.S. military, it's not as if it's actually that big of a deal if they get something wrong or if they can't respond to rapidly changing circumstances. And it's not like anybody's ever going to try to hack them, right? Except, of course, all of that's pure nonsense. So they do, in fact, rely very, very heavily on these processes because it helps make sure that everything gets properly accounted for, reduces the risk of human error, etc. And they've talked very, very publicly about that. I put the little Kubernetes inside because, again, kind of famously, the F-16 fighter jet runs Kubernetes for its flight systems. They won't say exactly what systems for pretty obvious reasons, but that's part of the reason why the Department of Defense is part of the CNCF, the Cloud Native Compute Foundation, and a pretty regular contributor to it is because they rely very, very heavily on these technologies. So if anybody tries to give you, but what I do is special excuse, isn't that special? You can ignore them, continue to make the world safe for democracy, but time to stop making fun of the dinosaurs. Let's move on. With the demands of today's operations, there's no longer any reasonable choice but to implement infrastructure automation that is repeatable, traceable, and less prone to human error. We're going to talk about each of these benefits of GitOps, common benefits for GitOps. But for now, because of the various guarantees, dev teams can self-provision their own infrastructure much faster. So it makes for a much faster move to production for development, or even into a development environment for them. It makes it easier to push code, not containers, which acts as the basis for functions as a service. Lambda and cloud functions and all those kinds of fun things. Increased auditability and policy enforcement. Since the system reflects the state in Git, we'll talk a lot more about that, and Git's trivial to update the state, including reverts. Mean time to recovery can be minutes or less, as opposed to hours to days for people reacting to things, because again, the computers can type much faster than you can. Since everything is automated, it's easy to standardize, and the various mathematical proofs from Git with runtime environment enforcement to match Git are very powerful for giving you those nice, strong security guarantees. So with that, Git in particular has some very nice features compared to, especially to other version control systems, prior version control systems. And that's immutable, it's secure, it's diffable, and it's auditable. Virtually all source code management systems before Git, could also meet those, but not as well as Git can. And it partly because of some of the ways that Git does that, it made it particularly useful for that. So Git is immutable. It uses Merkle trees, also known as hash trees, that use a secure hash, specifically the SHA-1, and therefore it's mathematically impossible for state to change without being obvious. So nobody's going to be like modifying the code inside there without you knowing. Even if it gets hacked, math is math. It hashes its state the entire way, and so it becomes really obvious if something is changed as part of that system. Git is secure. Beyond those guarantees that I was just talking about, just given to you by straight up math because it's a hash tree, Merkle tree, it's easy and common to digitally sign commits or annotated tags. One of the big use cases, the primary use case for Git, of course, it was created for the Linux source code. It was created by Linus Torvalds, who of course also, runs and manages, runs, manages, etc. The Linux operating system source code. Considering how much stuff runs on Linux, it would be really, really bad if you couldn't make like extremely strong security guarantees on that source code. And so that's one of the things that Git does. It's very easy to secure that code. And again, every company on the planet relies upon the fact that, including nation states, rely upon the fact that it's easy to secure that code. And so let's take advantage of the same thing that all of them do. It's diffable. What's particularly nice about Git is because it's not storing patches, it's storing the complete state at every step along the way. If you want a lot more information on this, I've got another talk on Git Made Simple that talks about Git data structures. But so with that, that means that comparing versions, whether it be the very first version or the 500,000th version in the repository, is simple, guaranteed, and fast. It's an O1 operation for all you computer science people. Git is auditable, which means that you take all that other stuff that comes through. You've got your security and the fact that it's guaranteed not to change. You can append to it, but you know exactly what's going on for each of those. If you have an ID, if you have that hash, then nothing underneath that hash is ever going to change. And regulatory compliance and the rest become much, much easier because you have all of those guarantees. So all of that, what does that have to do with GitOps and what we were talking about before? Again, Git manages for GitOps and manages the state of the system. So a new commit on a branch is a potential state and is verified through continuous integration. So the tests and stuff that you can run on it, linting, etc. We'll talk more about that. And pull request review or other form of code review. And then when it shows up on master, the continuous delivery sees it as the desired state and modifies the system to make that true. So you're asserting a set of facts about the state of the system, where you want it to be, and the system, those helper systems for GitOps help make sure that that is in fact true within some period of time. So it shows up on master. Hopefully you're all following the DORA guidelines. If you're not familiar with the DORA guidelines, DORA is Google's research and development initiative around DevOps, where they oversaw thousands of projects from different companies, talking to thousands, tens of thousands of developers and the rest to find out exactly what worked best and what doesn't. Gather together best practices around all of that, as well as kind of the systems and the rest associated with that. And that was DORA, their research group, and they have published a lot of that and have given guidelines from those best practices from doing all that research. So, please take a look at that. But one of the things that they talk about is trunk-based development, which kind of harkens back to Subversion. It should be called master-based development since everybody uses Git these days, but same idea. And we'll talk a lot more about the system coalescing around that state in Git in a little while when we talk about the how of GitOps. All right, so again, operators, this means that thou shalt not do anything except by way of CI/CD. Excuse me. And that includes configuration changes or anything else to the system. This means that there is no SSHing into machines. Not even going to talk about Telnet, but you're not connecting to the machines yourself to make changes to them, because that implies a state of those machines that is maintained outside of Git, and that's bad. If you do that, you're going to be punished because that state is going to very rapidly just get blown away by the GitOps system, by the CI/CD. Developers learned a long time ago that how bad it is to have stateful systems with just a few kind of edge cases where that gets maintained, but usually you try to get somebody else to maintain those stateful systems. Primary examples would be like web servers and the rest, where it used to be common where you had a web server, for example, that maintained its session state and everything inside that server. These days, you don't do that. You push that out to like a Redis server or something like that to push things out to some sort of persistent system that is designed very specifically for that state. And again, usually these days, maintained by somebody else. It's maintained by like your cloud vendor, where they can deal with all the headaches of state management and keeping those systems running and working correctly. That's no longer a developer's job for maintaining the state inside a system. Maintaining a state inside a system it doesn't scale, it doesn't do any of that kind of stuff. It's just a bad practice. And developers for the last decade have had their hands slapped many times by the real world whenever they try to do that. And now it's coming into the realm of operations as well. One bonus of all of this, that you can't change the state of a system without it getting blown away, is that means that if your system gets hacked, that hacked state is is a wound on the system, and therefore the next cycle time, basically the next time that the system checks itself, hey, am I still in the same state? That's going to get blown away. And so it's, again, a great way to help make sure that your system actually does reflect what you want it to reflect. And somebody trying to come in and modify it, it ain't going to happen. Or they've got a very limited window of opportunity for doing it. Certainly much less than a system that just kind of sits around for years. Nobody really takes a look at it. Certainly nobody audits its state and the files on that system or what's in its memory or any of that kind of thing for years at a time, which used to be common practice. That is increasingly not the case anymore. And of course, along with that is you can do your system logs and run diffs against them on what you expect. You can do alerting, machine learning analysis, and all those kinds of things for mitigations, because I'm not going to turn this into a full security talk, but you will get hacked. Hacking does happen. And so one of the next things that you deal with after securing the perimeter, securing the system, is what are your mitigations, and how do you detect that you have been hacked, and then what are your mitigations? And this makes it much, much easier to deal with all that. Now, code reviews for infrastructure as code. Lots of nice little acronyms there. Nobody in their right mind wants to review infrastructure configuration more than absolutely necessary. A whole lot of it is, monkey work. It's just the same thing over and over again. And that's one of the reasons why you don't want people to do it as much as possible, because your eyes glaze over. So you have computers for that kind of thing, specifically linters and the rest. Let them deal with the mind-numbing work. They don't have minds to numb. And let people deal with the much larger issues and patterns and ways of approaching those problems. Code reviews, since everything is becoming code, are becoming even more valuable than ever, and they've always been tremendously valuable. So you need to make sure that you're taking all this nonsense crap off of the table for the humans, and so that they can move on to much more sophisticated and, frankly, interesting problems. Some potential, these are just kind of common ones for linters. Linting is just static analysis. It goes back to a program that was used for static analysis of code from the C days. And so this is just, use a computer to look for patterns and the rest that have been identified in those, in that code, in that configuration. So our, Terraform linters, Terrascan, Chekhov, Deep Source are all, common places to go. The last one is commercial. All the other ones are open source. And in addition to linting, that's static analysis, you can also do runtime analysis and policy enforcement. And two of the more common ones for that would be like Cloud Custodian, which is also, all this is open source with the, noted exception, as well as like OPA, Open Policy Agent, for helping secure your, your authentication and authorization, particularly your authorization rules as they move through things. Much larger topic, but again, all of this means that this is run as code that's easily, easily pattern tested, easily verified, easily checked, easily tested into other systems before it actually shows up in your production system. So these can move up through deployment pipelines, like from development to testing to staging, to user acceptance testing, into production kinds of things, depending on what your pipeline looks like. These can follow the same route and therefore tested every step along the way and validated. So now we've talked about the what and why. Now let's talk about how do we make all this stuff work. A little bit of history so that you understand kind of where all this is coming from and therefore why where technology is. The term was coined by Weaveworks in a blog post that they gave just back in August of 2017. So not very long ago at all. But that's when it was coined. And that's certainly when it got popularized. And very similar to what happened with Agile, what happened with REST, some of these other terms is, the industry went, yes, that's exactly it. We've been doing it for a long time. Well, kind of. At least a lot of these different things, we recognize this in problems that we've had to solve. But now we have a name for it. Now we can start standardizing around it. Now we can start tooling around it. Now we can start arguing with each other around it and calling each other's names and heretics. But that's now that we have a name for it, we also have a common set of practices so that when you refer to GitOps, people have at least a vague understanding of what it is that you're talking about. Again, this stuff has been around for a long time because you just couldn't manage these systems without it. It's certainly longer than 3 years. But before Kubernetes and some of the tooling that has sprung up around it, as well as a lot of the stuff that comes from the major cloud providers, it's been possible to do. Of course, you absolutely could do it. If you could write automation, you could do it. But especially for that last mile kinds of stuff, for particular machines, keeping them up to date, all that kind of stuff, it's been a lot of bubblegum and duct tape. And so thankfully now that some of these other systems have matured, a lot of our practices have matured, that gives us a way of approaching these problems that are much more consistent. And therefore, again, we can move on to much bigger problems. The 4 principles that Weaveworks published, not in that article, because again, that was an introductory article in the years since. 3 of them, the last one is a little bit controversial. We'll talk about it. But the others, basically everybody just, yeah, of course, that's what GitOps is. You describe the entire system declaratively. You version the canonical desired system state in Git, which we talked quite a bit about. Automatically apply the approved changes to the desired state, and that's what the CD part of things is about. And then ensure correctness and alert on divergence with software agents. And we'll talk more about that at toward the end. So for that first one, everything's declarative. Declarative means the configuration is guaranteed by a set of facts instead of by a set of instructions. That's one of the reasons why it's almost always done by way of YAML these days. Is certainly by far the most popular. Also JSON, and there's a number of other languages similar. Not really languages as in like you're just that you normally think of it, but just ways of describing. It's kind of data protocols, ways of describing information. It's ways of describing facts. You're not talking about instructions. You're talking about facts. It's not iterative. It is declarative. And that makes it much, much easier for computers to deal with, to reason about, particularly to be able to do a diff against. It's like, what set of facts here? What's my set of facts here? What's the difference? And that's much easier to deal with than like applying a series of instructions. And that's why it's almost always goes into, here's a set of facts. And again, these days, primarily using YAML. which is just a superset of JSON. So if you, for whatever reason, you prefer JSON over YAML, same thing. Put JSON into a YAML parser, it'll parse it just fine. And in fact, as a practical matter, I sometimes do exactly that because sometimes the YAML format is a little funky compared to the JSON. So I mix and match because it's a superset. Anyway, all the major infrastructure as code diff capabilities have diff capabilities, such as kubediff, teradiff, Ansible diff. They all, so you can find out, hey, what's the difference, particularly between here's what's stored in Git, here's what my running system is reporting back to me, what are the differences, how can I apply that? And because of that, that enables the system to be self-healing because it can continually just, watch and make sure that its state hasn't changed compared to what it expects in its canonical form in the Git repository. Canonical version state. So with the declaration of your system stored in a version control system and serving as your system of truth, you have a single place from which everything is derived and driven. And again, what's really nice about this is that Git security guarantees make sure that nothing can be tampered with without you knowing about it. Apply those approved changes. As we talked about, the system is then compared to its desired state. The runtime system is compared to its desired state. And the larger system, we'll talk about exactly how this works in just a moment, gets compared, compares those two, finds out what the differences are, and then makes decisions on how do I bring it from my current state to the desired state. And it figures out the path for how to do that transition. And then the last one is agents ensure the correctness. So agents inside the system, inside your VPC and that kind of thing, constantly monitor to make sure that it's not only in the correct state has been applied, but it doesn't drift, which is a problem that a lot of the prior systems had to where, again, like if somebody SSH'd into a machine or just over time systems entropy as well, and therefore they would drift from the desired state from what you had originally applied to that system. And this kind of approach helps make sure that that drift doesn't happen, which gets to a lot of the kinds of things that we talked about for like the hacking and the rest. So that can't happen, at least not for very long, whatever your cycle time is on doing these checks. And so with that, that means that it becomes truly self-healing, because it's constantly making sure that what you think was supposed to be there actually matches what is there, because it's always making sure that that's the case. And it sees any deviations as a wound that the self-healing has to fix. Which gets to a couple of the different ways of applying this. This is the classic CI/CD approach that developers use all the time for moving code out, where you pass it, you check things into your repository, a CI/CD tool like Jenkins or GitLab or whatever, but your CI/CD tool then takes that code, that infrastructure as code, and applies it into your running system, into your cloud or whatever. And that's the push model. So you're pushing your state into the system from desired state into runtime state. The alternative to that would be the pull approach. And that's the approach that the newer systems like Argo CD and the like make use of, where they're running inside the system itself. They have various agents running on inside there with CRDs and fancy things, particularly with Kubernetes. that make it so Kubernetes, because it's also a declarative system that has a lot of these also continual monitors running through it, makes this kind of approach particularly nice, useful, and easy to where, again, it's not being applied to it, and therefore you're getting an opportunity for drift to happen. It's constantly self-inspecting and constantly self-inspecting, bringing itself to the state that is described in the Git repository. So with all of that, if you have something in your system that is not automatable for whatever reason, and or observable, then you can't automate it, or even properly operate it. So you want to make sure that that everything inside your system matches that. By default, virtually everything inside a modern cloud infrastructure does exactly that, matches those criteria, though you can work against it if you try hard enough. So don't follow the practices of your cloud provider to make sure that everything has health checks and all the rest of that in place. But with that, that means that you now have the ability to have these self-healing systems. So again, you can move on to bigger problems. So finally, what is GitOps? It's DevOps cranked to 11. Really pushing the ideas that were initially put forward for DevOps. And it's in many ways kind of the culmination of what the original founders of DevOps were going for. Why GitOps? You just can't do otherwise these days. Not in any way that's going to give you your nights and weekends back, because this is how you are able to scale so that, again, you can move on to much bigger, more interesting problems and not deal with all this low-level crap that the system now is able to take care of for you. And how GitOps, it's a set of principles that tool chains use for self-healing to make sure that, again, you can have your nights and weekends back. You can scale, you can be secure, you can do all that kind of wonderful stuff. All right, thanks.